Hello friends, welcome all of you to our discussion on nomenclature of heterocycles. So in continuation of our previous lectures, let us see in this session naming of heterocycles with fused rings. In case of heterocycles with fused rings, you can have two types of cases where one is a carbocycle fused with a heterocyclic system. In simple, the example is like benzimidazole, where you have a benzene fused onto an imidazole ring. So how to name this type of rings? And we can have heterocycles fused with another heterocyclic system. So here you have an oxazole fused onto a pyrazole. Let's see what are the different rules that we have for naming of this type of compounds. One is carbocycle fused with heterocyclic system. Let us say benzimidazole. In this case, the general rule that we need to follow, or the procedure that we need to follow, is here we have one ring attached onto the another ring. Like in case of organic compounds, where on the structure of an organic compound, if a substituent is there, like chloro is there on a benzene ring, so how do we call it? Chlorobenzene. That means you will have a main ring, on that some substituent is there. Similarly, in case of heterocycles, when there is a fusion of a ring across a bond onto another ring, we need to first see, we need to separate the two rings. Of course, naming will be there. And after separation, you will have two rings. Let us say here we have two rings. So now we need to decide whether this is the major ring or this is the major ring. In case of carbocycles, the situation is very much simple, where heterocycle is always considered as the major ring and carbocycle is always considered as the minor ring. Then how do we name it? Let us see on imidazole. If you see 1, 2, 3, this is the numbering that we had already discussed. Okay, this is the way how do we number it. And if you follow this number 1, 2, 3, 4, 5, because here we need to tell the people that a particular ring is fused onto a heterocycle across a bond. So because here 1, 2, 3, 4, 5, they represent only the atoms. So how do we represent the bonds? So for that, A, B, C, D, E, lettering. So we have another method of representing bonds via letters. So A means 1 and 2 atoms are joined via A. So which bond across which benzene is attached to imidazole? Because it is attached like this, so it is D. Benzo 1,3-diazole, okay, this is 1,3-diazole, okay. So these two are joined via the bond number D, bond letter D. So we represent carbocycle fused with heterocyclic system like the substituent or the minor ring here, and then major ring, and in between, in the square brackets, we mention the bond across which the fusion has happened. And because in case of benzimidazole, we have at one position H is there, one H is also mentioned over here. So this is the way how we give numbering or name when we have a carbocycle fused with heterocyclic system is there. Name of the substituent ring or the minor ring, number letter, name of the base ring or the major ring. So this is the format that we have for giving name to a fused heterocycle. Let's see another example. This is we all knew this one. This is phenothiazine. A phenothiazine ring is very, very important to pharmacy because we have certain drugs like chloropromazine, which is a very strong antipsychotic drug. So now let's see how to give name to this ring, technical name, because there are two rings are there, so we need to separate them. So we have benzene and heterocycle ring, and then another benzene ring. So two minor rings and one major ring. So how do we give a name or number? Because here we start from sulfur 1, 2, 3, 4, 5, 6. This is ordinary numbering. Now A will come. Now can you tell us how to fuse them together? We have at 10th position H is there. So that is the dibenzo BE, B and E, 1,4-thiazine, 1,4-thiazine, 1,4-thiazine. Okay, so this is the way how to give name to a heterocycle fused onto a carbocycle. I hope it is clear to all of you. So we'll move ahead. This is phenothiazine. Now let's see how to name heterocycle fused with another heterocyclic system. So let's see a small example here. So here we have a heterocyclic ring where we have two rings are there. Both rings are heterocycles. They are fused to each other across a bond. Now here let us see whether the rules are the same or any other difference is there. So we follow our regular procedure. So we split the ring into two across the bond. So we get obviously two rings. One is a pyrano ring, then the pyrrole ring is there. Now the problem comes. So which is the minor ring and which is the major ring? So for which we have certain rules and regulations. That is what we call it as a priority order of component ring system. So here we have certain rules. About 7 rules are there. Let's see every rule and an example case study we'll see in this presentation. Let us say in case of rule 1, a heterocyclic ring containing the heteroatom occurring earliest in the order N, O and S. That is, the ring containing N is preferred to the rings that does not contain N or containing oxygen or sulfur. Let us say in a ring there is only one atom, one heteroatom is there, and then what it could be? Let us say in the first chance, the ring containing N is considered as should be considered as the major ring. So then pyrano ring, though it is bigger, we consider it as a minor ring. Pyrrole ring is considered as a major ring. Okay, pyrano, pyrrole. Now in the next step, after splitting the rings, in the next step we have to give numbering. So here numbering is important for the minor ring, and here we are giving numbering to the major ring in order to assign order of bond order. Okay, letters A, B, C, D. Then we will have to tell how these two rings were fused together, because in case of benzene there is no specific order that is needed because all 6 bonds in benzene are the same. But here we need to tell them across which bond fusion is happening as well as which atoms of the heterocycle is they are involved in the fusion, and in which direction we have to see. That means here numbering is happening 1, 2, 3, 4, and here lettering is also happening A, B, C, D, the same direction. Hence we will name 2, 3, the same direction 2, 3, because we always have to consider major ring as the deciding factor. So here how actually lettering is going on A, B, C, D. Okay, so in the clockwise direction. Here we have to take anti-clockwise. So because in the same direction it has to go. So same direction it is going. So 1, 2, 3, 4. So 2, 3 is the order in which it is fusing onto the C. So we will see this kind of method in the next rings also. So it will be much clear to you as to how we have to consider the direction also. Okay, so I hope it is clear to you. So this is the way one way to decide whether it is a minor ring or a major ring, because based on the atom we are deciding here. So if nitrogen is preferred over oxygen is preferred over sulfur, it is as simple as that. It has nothing to do with the ring size. For one, next one is while representing the fusion point, we have to see obviously, because this you already have seen the bond. But while giving which atom in which direction the minor ring is fusing onto major ring direction, actually the direction in which the atoms are represented decides the way how we have to give numbering for the minor ring fusion points. Okay, so let's go ahead. So numbering system for the whole fused ring is not the same as the numbers in the square bracket. That is what we have to see, because here if you see the number for the ring system is not the same as the numbers we are giving for individual rings. Second one, heterocyclic component containing largest possible individual ring. Okay. If both atoms in the heterocycles, both the heterocycles are the same, if both are the same, then size does matter, because earlier atoms are what we are taking into consideration. So when nitrogen is there, that has to be preferred over oxygen, then oxygen over sulfur. It is like that. So here, because both are oxygens, let us say both are oxygens, then both rings are the same. So whatever is bigger in size, we have to consider it as the major ring. Okay, for major ring, what is it that we give? Letters A, B, C. And then for minor ring, we give numbering 1, 2, 3, 4, 5. So we are mentioning only the important atom numbers only. Then this is minor ring. So minor ring should come first, furo, because this is a furon, this is a pyron. Then how do we represent the junction point? Because bond is B. Yes. So how do we give a lettering? So here this is going in anti-clockwise direction. This also has to be considered in the anti-clockwise direction. So if we go in the anti-clockwise direction, it will become 3-2. Furo 3-2B pyron. Furo 3-2B pyron is what we need to give. This is the technical name for this compound. But here, if you see, we have a saturated carbon over here where you can find H. So to localize, or otherwise we need to give location for the hydrogen. That is what we have already seen in the earlier cases. But here, let's see how to decide the numbering. So while giving numbering for a heterocycle, fused heterocycle, we always have to start from next to this quaternary carbon, and we must always start from next to quaternary carbon and have to go from here to the clockwise direction. If we start from here, you go in the clockwise direction. If we start from here, you go in the clockwise direction. Or if you wanted to start from here, you move in the anti-clockwise direction. So if you are starting from here, you have to go in the anti-clockwise direction, but never move towards the quaternary carbon. So you start from here and moving on to quaternary carbon is not correct. So if you start from here, you should move in this direction, but you should not move in this direction. Okay. So if you start from this oxygen, Now let us see how to give numbering. 1, 2, 3, 4, 5, 6. Okay, it will go on. So here if you see another way, so if you start from this oxygen, 4, 5. So if you see the total, this oxygen has 1, this oxygen has 4. When you start giving numbering like this, and in this case oxygen is getting 1 and 5. 1 and 4 is better than 1 and 5. Obviously 1 and 4 is better than 1 and 5. So this is preferred. So where exactly the H is there right now? At the second carbon. So that's why it is preferred. So we mention it as 2H fluoro 32B pyran. Okay, this is the major ring, this is the minor ring. This is the direction of direction in which the atoms on the minor ring are fused onto B bond of major ring. And in this structure, in this entire structure, at the second position you have the hydrogen. So that is the meaning of the entire name. I hope you got it. So let's move ahead. The third rule is a heterocyclic component containing the greater number of heteroatom of any kind. That means we have two rings. So in one ring we have two heteroatoms, in the second ring we have only one heteroatom. So if we do a minor ring and major ring, splitting of the rings, so this is the way how we would split it. So the ring containing less number of heteroatoms is always considered as the minor ring, and the one with more number of heteroatoms is always considered as the major ring. So here also we need to give first numbering. So here we are giving numbering according to IUPAC nomenclature only, because earlier in my first video on heterocyclic nomenclature there is a detailed explanation on how to give numbering for a simple heterocyclic ring. Okay, so if you get any doubt, you please go back and refer, watch it again. Okay, then what is the next thing that we need to do? For major ring we need to give the letters. Okay, so across this D fusion is happening, and next one is 2 and 3 atoms of the minor ring are fusing onto major ring. Okay, let's give numbering, because the pyridine is the minor ring, so we give pyrido. Always please remember that this is the technical name for this one is azine. So in order to reduce complexity, so IUPAC nomenclature, otherwise Hansch-Widman nomenclature, allows common names to be used, like imidazole, indole, pyrrole. All of them are common names, so we can use them. Pyrido, like chlorine. If you have chlorine, we call it as chloro. Okay, so in the benzo, like that. So pyrido. What is this one? 1, 2 oxygen. 1, 2 oxygen is this ring. Then so it is moving in the clockwise direction, because A, B, C, D, this is the clockwise direction, so this must be anti-clockwise direction. Then 2, 3, because if you follow the same order, 2, 3, 2, 3, D. Okay, and here also again we have a hydrogen somewhere. So how to locate it? If you take this ring, one way of giving numbering is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so these are the two ways I am representing here. You can also go from this position and you can go all over this ring, or you can start from here and you can go all over this ring again and again and again. So in either way this is preferred, because the heteroatoms are getting 1, 6 and 7. Okay, 1, 6, 7. But here if you see in this way, heteroatoms will get 2, 3 and 5. Let's say you are starting from here, then what is the number it will get? If you are starting from here, 1, 2, 3, 4, 5, 6, 7, 8 means 2, 3 and 8 will come. If you are starting from here, 1, 2, 3, 4, 5, 6, 7, 8 means 4, 6, 7. So the heteroatoms shall always get more than 1. This is the only ring where nitrogen shall get 1. Okay, so the least number is needed to be kept for the major atoms like heteroatoms. And in another way we can see like the overall number given to different heteroatoms must be minimal all the time. So now it is, what is the position? 5H. 5H pirido, 2,3D, 1,2 oxygen. Sorry. The whole molecule is numbered starting from pyridine ring to give the 3 heteroatoms the lowest locants 1, 6, 7. However, starting from oxygen ring will give them locants 2, 3, 5 or 2, 3, 8 because 2 is a very, very high number for us. Next one is a heterocyclic component containing greater variety of heteroatoms. Let us say both are having same number of heteroatoms. So here we have oxygen, nitrogen. Here we have 2 nitrogen. So whatever contains greater variety of heteroatoms shall be considered as the major ring. So if we split the ring, now we have an oxazole and a pyrazole. So this is the major ring because it has oxygen and nitrogen, and this shall be considered as a minor ring because low variety. This has greater variety. Now if we go in the regular method, first we give the numbering and lettering to the ring, because if we see this is oxazole. In case of oxazole, we start from oxygen while giving number. So 1, 2, 3, 4 and 5. So if we move in this direction, so A will come here, B, C and D. What is the direction? Anti-clockwise direction. Okay, so these are the things that we need to understand. First, you take the ring, split it, decide which is the major ring, which is the minor ring. For both the rings, give numbering as per IUPAC or Hand-Schweidman nomenclature. Then for the major ring, give letters to represent the bonds. So 1 and 2 atoms, the bond between 1 and 2 atoms is A. 2 and 3 atoms is B. 3 and 4 atoms is C. 4 and 5 atom is D. So it is as simple as that. And then here we keep the numbering to represent across which atom the bond is fusing on to major ring. So this is a pyrazole. So pyrazole O. So this is an oxazole. Oxazole means 1, 2 oxazole only. Okay. So let us say oxygen, if it is over here, it will become isoxazole. So that's why oxazole means this. Then, so here it is anti-clockwise direction. So it must be clockwise direction for the minor ring. So 4, 3, D oxazole. So is there any hydrogen somewhere? No, nothing is there. So we need not bother about the hydrogen. But here on nitrogen you have a hydrogen. So we need to represent where exactly you have the hydrogen. So if we give numbering, we start from nitrogen, then 1, 2, 3, 4, 5, 6. Let's take another thing, nitrogen. We start from nitrogen, 1, 2, 3, 4, 5, 6. So this is preferred because if you see the numbers that we are getting for nitrogen, 1, 2, 4 here it is 1, 4, 5. Okay. So the whole molecule is numbered starting from pyrazole ring to give 4 heteroatoms the lowest locants 1, 2, 4, 6. While starting from oxazole ring, give them locands 1, 3, 4, 5 or 1, 3, 5, 6. That is bigger than this one. So we need to see how actually the overall heteroatoms are getting the numbers. Okay, so we start from next to this quaternary atom and we do either clockwise or anti-clockwise. Here it is clockwise, and if we start from oxygen, it is anti-clockwise. Okay, so overall atoms shall get least numbers, least locands. So 1H, so because it is there in 1, so 1H pyrazole 4,3D oxazole. So it is a sequence, so if you follow the sequence, it is very easy for you to name any kind of these fused heterocycle systems. Now let's move on to the fifth rule. A heterocyclic component containing the greater number of heteroatoms most preferred when considered in the order oxygen, sulfur and nitrogen. See here, for both the rings, 2 atoms are here, 2 heteroatoms are here, 2 heteroatoms are here. So one nitrogen, the other one is a different heteroatom. So now, so if you see the previous rule where heterogeneity is actually taken into consideration to identify the major ring. Now here both are of same heterogeneity. Now how to decide? So here the atom which is to be preferred is oxygen or sulfur over nitrogen. Okay. Now if you follow the regular procedure, we split the ring into 2 so that we get here an oxazole and a thiazole. So according to this rule, which is the major ring and which is the minor ring? Because considered in the order of oxygen, so when oxygen is there, that should be preferred over the sulfur. So this will be, oxazole will be the major ring and then thiazole will be the minor ring. So let's go ahead with the numbering. 1, 2, 1, 2, 3, 4, 5. And here this is 1, 3 oxazole. What about this one? 1, 3 thiazole, because this is the substitution. Okay, then we give the letters to the major ring. The bonds represent bonds of major ring, and if you see the way how it is getting, so it is clockwise direction, so it must be anti-clockwise on the minor ring. So if it is, you are coming from anti-clockwise direction, 5, 4. Okay, thiazole 5, 4, D. Across D the bond is getting fused. 1, 3 oxazole, 1, 3 thiazole. So in the earlier case, when oxazole is there, pyrazole is there, we are not mentioning the numbers. Okay, because here to represent it, 1, 3 thiazole, 1, 3 oxazole, 1, 3 thiazole. So this is the classical way of representing it. If you are not mentioning it, it means again it is thiazole only, but it will become a little bit complicated. If you mention it like this, it will be more plain to understand. Okay, so 1, 3 thiazole means in the rings, after splitting in the individual rings, the positioning of heteroatom is 1, 3 thiazole and 1, 3 oxazole. Okay, 1, 3 oxazole, and the fusion is happening across 5, 4 atoms of minor ring and D bond of the major ring. Okay, so this is the way how we need to understand. Even if you remove 1, 3, it doesn't matter. Rule 6. A heterocyclic component with lower possible number for heteroatoms. Lower possible number or locant for the heteroatom. So here we have 2 nitrogens on one ring and 2 nitrogens on the second ring. So if we do a regular naming, So first we split it. So we have two rings. Now you decide which is major ring, which is the minor ring. So according to this rule, heterocyclic component with the lower possible number for or locant for heteroatom. So here if you start from here 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. For this one 1, 2, 3, 4, 5, 6. Okay. So obviously these two nitrogens are getting 1 and 4. These two are getting 1 and 2. Now you can tell me which is the major ring and which is the minor ring. So the heterocycle component with the lower possible number for heteroatoms means this one must be the major ring. This is the minor ring. Now let's go ahead, try name this compound. So what is the next thing we do? We give letters to the bonds. So in which direction it is moving? Clockwise. Clockwise means like this. So this must be anti-clockwise. So if you are moving from in the anti-clockwise direction, 1, 2, 3, 2, 3 will come. This is pyrazine. This is pyrazine. This is pyridazine. And then 2, 3. The name of the compound is identified as pyrazino 2,3-D pyridazine. Okay, so this is pyridazine, this is pyrazine, and then 2,3-D. So I hope you are able to understand this one. So we will move ahead with the next rule. The rule 7: if a position of fusion is occupied by a heteroatom, the name of the component rings to be used are so chosen as both to contain the heteroatom. So this rule, let's make it simple. Let's say if you have this heterocycle where at the point of fusion across this bond, let us say a heteroatom is there. Then how do we do the splitting part? So if we split it, it's very simple. Have the heteroatom in both the rings. Have the heteroatom in both the rings. Now you apply general rules to decide which is the major ring, which is the minor ring. Now can you tell me which is the major ring and which is the minor ring? Which rule helps you decides that? If the number of heteroatoms is the same, then that ring with more diversity, heterogeneity, is considered as the major ring. So that is the rule that we had just now seen. Now we give numbering to the minor ring and lettering to the major ring. Because here, let us say if you give this one, this is the thiazole ring. So we start from sulfur. S1, 2, 3, 4 and 5. So because 1 and 2 atoms, so we get a letter A here, 2 and 3, letter B here, 3 and 4, letter C here. So here it is obvious, okay. We start from the saturated nitrogen, 1, 2, 3, 4, 5. Okay. So now let's try giving a name for this. This is imidazo, because this is the minor ring. Imidazo 2, 1, because if you see the direction in which it is moving, it is in the anti-clockwise direction. So it starts from here and is going through like this. So we have to take clockwise direction for this. So 2 and 1, 2, 1, B thiazole. So is it not simple? Friends, I hope you found now you understood the nomenclature of heterocyclic ring for the fused heterocyclic rings. Now let's move on to newer one, that is bridged heterocycles. Bridged heterocycles are slightly tricky. We'll see that, like in the best example that we have is atropine. Okay, in atropine we have a propane ring. Propane ring is a bridged heterocycle where, so if it is connected via more than one atom, so we call it as a bridged heterocycle. Okay, bridged heterocycle. If it is directly joined, then it is like two heterocycles. But if you see this one, this is not a bond, because there is an atom which is splitting it, so it is something like a bridge. Okay, so these are bridged heterocycles. In natural products we can find several examples for this. So we'll continue this discussion further in the next lecture session. Friends, I hope you understood the method for giving a name to a heterocycle. So if you have any doubt, please post it in the comment section, and we'll meet again soon in a new lecture on rigid heterocycles. Okay. Thanks for your time, and see you again soon. Bye bye.